Magical book on quicker maths.
Magical book on quicker maths. Warning: empty page. Magical book on quicker maths BSc PIB, Ishin Co., Private, Ltd, C. 37, Kangxi and AC, /R.P. Vndav Nagar Complex Delhi -110,092. BSc Publishing Co., PVT, Ltd published by Rin, ed. at First Indian Edition 1960 C. 37, Ganesan I. Agar, Pandav Nagar Complex, Delhi 110092 Madhu Offset Press 431, Jharkhandi Road, BN. Nagar, Shadara, Delhi -110,032. Dedicate to Sri Jagdeo Singh Il, Adaji. Distributors list: L and S Careers, B. 2369, Sector 2, Salvi, HEC, Ranchi. 2. Gita Pustak Ken, JRA 4-2-771, Ramkot, in front of Nav Chaitanya Junior College, Hyderabad. 3. Nilkama. Book Distributors, 0 pp. Clock Tower, Sultan Bazaar, Hyderabad. 4. Usha Book International, Road No. 7, Rajendra Nagar, Patna. 5. International Book Trust, College Street, Calcutta. 6. Basant Book Stall. 2. Dakrix Lane, Calcutta, 69. 7. Asherwad Book Depot, Aminabad Book MKT, Lucknow. 8. Universal Book Center, all branches, Lucknow. 9. Prayag Pustak Bhavan, 20 A University RD. Allahabad. 10. Vishwavidyalaya Prakashan, Chowk, Varanasi. 11. SK. News Agency, 73/3, Sutar Khana, Kanpur. 12. Sham Sundargupta, 133-169, M Block, Ridwai Nagar, Kanpur. 13. Mohapatra Book Distributors, 83, SCR, Caravel Nagar, Unit LII, Bhubaneswar. 14. AK. Nayak, Old Bus Stand, Ashok Nagar, Bhubaneswar. IS. AK Mishra Agencies, Banka Bazar, Katak, 2PH, 34327. 16. Mutta Bookstore, Op Government Bus Stand, Badambodied, PO, Talatalanga Bazar, Katak, 9. 17. Liberty Book Depot, 67 Below Bridge, Gandhi Road, Ahmedabad 1. 18. Bindu Book Stall, 104, First Floor, Alankar Apt, Dandya Bazar. Char Rasta, Op. Police Chowki, Baroda 1. 19. Gaurav News Agent, Hanuman Chowk, Jaisalmer. 20. GMD Book House, MP University Campus, Summer Hill, Shimla. 21. EBS News Agency, 1701, Sector 22B, Chandigarh. 22. Variety Bookstore, SCO, 69, Sector 17D, Chandigarh. 23. JK Book Center, Op Bus Stand, Patiala. 24. Iqbal Singh and Sons, Ambala Kant. 25. Book Center, Chowra, Rasta, Jaipur. F. Sol DISTRIBL, Tour for South and West India Abhishek Book Distributor, registered, F. 206, Vikaspuri, New Delhi 110018. PH. 559-0340-561-1347 OH. 5525014 Showroom. Contents, Chapters, Page Number 1. Addition 1 Multiplication 9-3. Division 27-4. Divisibility 30-7-5. Squaring 45-6. Square root 49-7. Cube 55-8. Cube roots of exact cubes 59-9. HCF and LCM 6310. L. Acleans 70-911. Decimal fractions 90-112. Elementary Algebra 1-0913. Surds 147-14. Number system 15315. Binary system 18916. Permutation and combination 190,517. Probability 21318. Ratio and proportion 22319. Partnership 260,320. Percents C*270,321. Average 305,22. Problems based on ages 315,23. Profit and loss 323,24. Simple interest 377.25. Compound interest greater than 397.26. Allegation 417.27. Time and work 449.28. Work and wages 479.29. Pipes and cisterns 485.30. Time and distance asterisk 497.31. Races and games 525.9. 32. Trains 530.133. Streams 555.34. Elementary mensuration 1,560.535. Elementary mensuration greater than 11,595.36. Series 619.37. Approximate values 640.138. Data sufficiency 653.39. Calendar 693.40. Clocks 699.41. Logarithm 707.42. Data analysis 717x. Forward. When did you get up this morning? At 6:35. Did you reach your destination in time? Yes, I arrived 10 minutes earlier even though I got up 5 minutes late. One usually walk, but today I took a bus. Why not a taxi? Isn't it faster? Faster, yes. But in my case the speed of the bus was sufficient. Besides, I compared the fares of the two means of transport and concluded that taking a taxi would mean incurring unnecessary expenditure.
Wow.
What a clever guy. Saves money, saves time. Does he know some magic? Is he a student of occult sciences?
No, dear.
He is an ordinary mortal like any of us. But he exudes an uncommon confidence, thanks to his ability to compute at a magical pace. In other words, quicker maths is an asset at every step of phone's life. By quicker maths, the book means speed and accuracy at both simple numerical operations and complex problems. And it is heartening that the book takes into account all kinds of problems that one may encounter in the ordinary run of life. There are several books one comes across which take care of problems asked in examinations, but they are conventional and provide solutions with the help of detail method. This book provides you both die detail as well as the quicker methods. And it is in the latter that the book is irresistible. That the book provides you both the methods is a pointer to the fact that you are not being led into a faith where you have to blindly follow what Thegwaslashem says. The conclusions have been rationally drawn. The book therefore serves as a guide, the true function of a GI/N/, and once you get well versed with the book, you will feel empowered enough to evolve formulas of your own. One think the real magic lies there. At the same time, a careful study of the book endows you with a magical ability to arrive at an answer within seconds. There may be some semi-educated persons who sneer at this value of the book. Can you beat a computer? A contemptuous question is asked. Absurd question. For one, the globe is yet to get sufficiently equipped with computers. 2. Even when we enter a full-fledged high-tech age, let us hope it is not at the cost of our minds. Till not computers and calculators become the proverbial Frankenstein's monster, the mind is a healthy organ and computing a healthy function. Computers and calculators were devised by the brain to aid it, not to consume it. That the mathematical ability of the brain be intact is a concern of every individual. In most of the examinations, even calculators are not allowed, let alone computers. And it is here that this magical book proves immensely useful. If you are a reader of this book, you can definitely feel more confident, miles ahead of others. There is no doubt that there has been a lot of labor involved in the book. For all those students who are gearing up to drive their mathematics Marties at an amazing 200 kilometers per hour, the book definitely provides the requisite infrastructure. And what is more, the methods are accident-free with proper cautions at necessary places. Here is a book that will help exam takers glide and enthusiastic students enjoy the ride. In an age when speed is being maniacally pursued, a careful study of the book will serve as a powerful accelerator. At the same time, its simple language makes it easily accessible across the linguistic barriers. Besides, the fact that you vividly sec the quicker method makes things very interesting. And so the book provides you speed not at the cost of joy. It is not merely a mechanical device, but has an organic charm. One concludes, fast driving is fun. Chetananand Singh, editor. Banking Sun Ice's Chronic, Zil. Author's preface. We at Banking Sun Ice's Chronicle, BSc, analyze students' problems. If a student is not able to perform well at an exam, our research group members try to penetrate the student's psyche and get at the roots of the problems. In the course of our discussions, we found that the mathematics section often proves to be the Achilles heel for most of the students. Letters from our students clearly indicated that their problem was not that they could not solve the questions. No, the questions asked in general competitions are in fact so easy that most of the students would secure a 100% score if it were not for the time barrier. The problem then is inability to solve the question in time. Unfortunately, there was hardly any book available to the student which could take care of the time aspect. And this prompted the BSc members to action. We decided to offer a comprehensive book with our attention targeted at the twin advantage factors, speed and accuracy. Sources were hunted for Vedic mathematics to computer programmings. Our aim was to get everything beneficial from wherever possible. The most encountered questions were categorized, and quicker methods were intelligently arrived at and diligently verified. How does the book help save your time? Probably all of you learnt by heart the multiplication tables as children. And you have also been told that multiplication is the quicker method for a specific type of addition. Similarly, there exists a quicker method for almost every type of problems provided you are well versed with some key determinants and formulas. For the benefit of understanding, we have also given the detail method and how we arrive at the quicker method. However, for practical purposes, you need not delve too much into the theory. Concentrate on tie-working formula instead. For the benefit of non-mathematics students, the book takes care to explain the oft-used terms in an ordinary language, so that even if you are vaguely familiar with numbers, the book will prove beneficial, for it is self-explanatory. The mathematics students are relatively in a comfortable position. They do not have to make an effort to understand the concepts. But even in their case, there are certain aspects of questions asked in the 13 competitive exams which have been left by them untouched since school days. So a revision is desirable. In the case of every student, however, the unique selling proposition of the book lies in its ability to increase the student's problem-solving speed. Due caution has been observed to proceed methodically. A gradual progress has been made from simple to complex examples. There are theorems AIKL solved examples followed by exercises. A systematic, chapter-by-chapter study will definitely result in a marked improvement of the student's mathematical speed. IT students are requested to send their responses to the book and suggestions for further improvement. And, finally, one would extend my thanks to all those who've played a role in making the book available to the reader. One specially thank Mr. Madhukar Pandey for having played a key role in promoting the endeavor, Mr. Chetananand Singh for the meticulous editing of the book, and Mr. Naranjan Bharti for having carefully verified the results. Mr. Naranjan Singh's all-round assistance cannot be forgotten. Friends kept on encouraging me at every step. The inspiration one received from Mr. Sanjay, Mr. Devin Bharti, Mr. Nagendra Kumar Sinha, Mr. Sandeep Verma, Mr. Manoj Kumar, Mr. Vijay Kumar, Mr. Rajiv Raman, Mr. Anil Kumar, and Mr. J.K. Singh, to name a few, has been invaluable. And thanks to Mr. Pradeep Gupta for For printing preface to the second edition, it is a great pleasure to note that Magical Book on Quicker Maths continues to be popular among the students who are looking for better results in this cutthroat world of competition. This book has brought the new concept of time-saving quicker method in mathematics. So many other publications have tried to publish similar books, but none could reach even close to it. The reason is very simple. It is the first and the original book of its kind. Others can only be duplicate and not the original. Some people can even print the duplicate of the same book. It will prove dangerous to our publication as well as to our readers. So, we suggest our readers to confirm the originality of this book before buying. AFCAT confirmation is very simple. You can find a 3-dimensional hologram on the cover page of this book. FI's edition has been extensively revised. Mistakes in its first edition have been corrected. Some new chapters like permutation, combination, probability, binary system, quadratic expression, etc. have been introduced. Some old chapters have been rewritten. Hope you will now find this book more comprehensive and more useful. 14. Addition. In the problem of addition, we have two main factors, speed and accuracy, under consideration. We will discuss a method of adding, on which is faster than the method used by most people and also has a higher degree of accuracy. In the latter part of this chapter, we will also discuss a method of checking and double-checking the recites. In using conventional method of addition, the average man cannot always add a fairly long column of figures without making a mistake. We shall learn how to check the work by individual columns without repeating the addition. This has several advantages. 1. We save the labor of repeating all the work. 2. We locate the error, if any, in the column where it occurs. And 3. We're certain to find error, which is not necessary in the conventional method. This last point is something that most people do not realize. One of us has his own weaknesses and own kind of proneness to commit error. One person may have the tendency to say that 9 times 6 is 56. If you ask him directly, he will say 54, but in the middle of a long calculation it will slip out as 56. If it is his favorite error, he would be likely to repeat it when he checks by repetition. Totaling in columns, as in the conventional method of addition, we write the figures to be added in a column, and under the bottom figure we draw AH, so the total will be under the column. When writing them, we remember the mathematical rule for placing the numbers is to align the %ht hand-side digits when there are whole numbers, and the decimal points when there are decimals.
For example,
write asterisk hand-side digits, decimal alignment 4,234 13.0, 5,823 8, 2.51 640, 6,539.65, 2,532 1, 2,430 1.0, 0, 0, 3, 350 49.24 89. The conventional method is to add the figures down the ht hand column for +8 +6 and so on. You can do this if you h. 2 quicker maths in the new method, but it is not compulsory. You can begin working or any column. But for the sake of convenience, we will start on the right-hand column. We add as we go down, but we never count higher than 10. That is, when the running total becomes greater than 10, we reduce it by 10 and go ahead with the reduced figure. As we do so, we make a small tick or check mark beside the number that made our total higher than 10, for example. For 8, 4 plus 8, 12. This is more than 10, so we subtract 10 from 12. Mark a tick and start adding again. 6, 6 plus 2, 8j, 1, 1 plus 8, 9, 0, 0 plus 9, 9, 9, 9 plus 9, 1, 8. Mark a tick and reduce 1, 8 by 10. Say 8. The final figure, 8, will be written under the column as th, running total. Next, we count the ticks that we have just made as we drop lows. As we have 2 ticks, We write 2 under the column as the tick figure. The example now looks like this. 4,234, 8,238, 646, 5321350, 9989. Running total, 8 ticks. 2. If we repeat the same process for each of the columns, we reach the result 4,234 to the power of 23 653 21,350 m. Running total, ticks, 6,558 2222. Addition 3. Now we arrive at the final result by adding together the running total and the ticks in the way shown in the following diagram. Meaning total, 065S80 \\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\\0222220 total, 287778. Save more time. We observe that the running total is added to the ticks below in the immediate right column. This addition of the ticks with immediate left column can be done in single step. That is, the number of ticks in the first column from right is added to the second column from right, the number of ticks in the second column is added to the third column, and so on. The whole method can be understood in the following steps. Step 1. 42,348,238 inch 6,465,321,350 to the power of 9989 total. 8. 4 plus 8 is 12. Mark a tick and add 2 to 6, which is 8. 8 plus 1 is 9. 9 plus 0 is 9. 9 plus 9 is 18. Mark a tick and write down 8 in the first column of total row. Step 2. 423482 38 feet 646 inches 5,321,350 to the power of 9 total. 7 8. 3 plus 2, number of ticks in first column, is 5. S plus 3 is 8. 8 plus 4 is 12. Mark a tick and carry 2. 2 plus 2 is 4. 4 plus 5 is 9. 9 plus 8 is 17. Mark a tick and write down 7 in second column of total, row. In a similar way we proceed for third and fourth columns. 4 quicker maths 4234 23 IU 5 321 350 44 I9 total 28778. Note, we see that in the leftmost column we are left with 2 ticks. Write down the number of ticks in a column left to the leftmost column. Thus we get the answer a little earlier than the previous method. One nice illustration. Q 707.325 plus 1923.82 F 58.009 plus 564.943 plus 65.6 equals? Solution: 707.3251 218258 foot.00 64 43 5.6 total 3,319.697. You may raise a question. Is it necessary to write the numbers in Kalyan and Fon? The answer is no. You may get the answer without doing so. Question W written in a row form causes a problem of alignment. If you get command over it, there is nothing better than this. For initial stage, we suggest you a method which would bring you out of the alignment problem. Step I. Put zeros to the right of the last digit after decimal to make the no of digits after decimal equal in each number. For example, the above question may be written as 707.325 plus 1923.820 plus 58.009 plus 564.943 plus 65.600. Step 2. Start adding the last digit from right. Strike off the digit which has been dealt with. If you don't cut, duplication may occur. During meaning total, don't exceed 10. That is, when we exceed 10, we mark a tick anywhere near about our calculation. Now go ahead with the number exceeding 10. 707.32 plus 1923.82 58.00 plus 564.94. plus 65.60 equals 7. Addition 5s plus 0 is 5. S plus 9 is 14. Mark a tick in rough area and caney over 4. For plus 3 is 7. 7 plus 0 is 7. So write down 7. During this, we strike off all the digits which are used. It saves us from confusion and duplication. Step 111 asterisk add the number off ticks in rough with the digits in second places and rub off that tick from rough. 707.3 carat dollar plus 1923.8 carat plus 58. For F plus 564.94 J plus 65. 97I number of tick plus 2 is 3. 3 plus 2 is S. 5 plus 0 is 5. S plus 4 is 9 and 9 plus 0 is 9. So write down 9 in its place. Step 4. 707. Happy face. F1923. Plus 58. Happy face carat plus 564. P4. Plus 65.4 H. Underscore 0.6973 plus 8 is 1 1. Mark a tick in rough and carry over 1. 1 plus 0 is 1. 1 plus 9 is 10. Mark another tick in rough and carry over 0. 0 plus 6 is 6. So put down 6 in its place. Step V. I caret AST step. Following the same way, get the result. Plus 1 is equal to 3,319.697 addition of numbers, without decimals, written in a row form Q. 53921 plus 6,308 plus 80, 6 plus 7,025 plus 11,132 equals? Son. Step 1. 53,921 plus 6,308 plus 86 plus 7,025 plus 11,132 is equal to 2. Step 11. 53,921 plus 6,308 plus 86 plus 7,025 plus 11,132 is equal to 72. Step 3. 53,921 plus 6,308 plus 80, 6 plus 7,025 plus 11,132 is equal to 472. Step 4. 53921 plus 6,308 plus 86 plus 7,025 plus 1,132 equals underscore 8472. Step V. 53,921 plus 6,308 plus 80, 6 plus 7,025 plus 11,132 is equal to 78,472. Note. This method should be got good command over because it is very much useful and fast calculating method. If you don't understand it, try again and again. Method of checking the calculation. Digit sum method. This method is also called the Ninck's remainder method. The concept of digit sum consists of this. We get the digit sum of a number by adding across the number. For instance, the digit sum of 13,022 is I plus 3 plus 0 plus 2 plus 2 is 8.
2.
We always reduce the digit sum to a single figure if it is not already. 6 quicker maths a single figure. For instance, the digit sum of 5,264 is S plus 2 plus 6 plus 4 is 8, 17, or 1 plus 7 is 8. 3. In adding across a number we may drop out 9s. Thus, if we happen to notice 2 digits that add up to 9, such as 2 and 7, we ignore both of them. So, the digit sum of 990,919 is 1 at a glance. If we add up 9s, we get the same result.
4.
Because 9s don't count in this process as we saw in 3, a digit sum of 9 is the same as a digit sum of 0. The digit sum of 441, for example, is 0. Quick addition of digit sum. When we are adding across a number, as soon as our running total reaches 2 digits, we add these two together and go ahead with a single digit as our new running total. For example, to get the digit sum of 8865,429,3285 we do like 8 plus 8 is 16, a two-figure number. We reduce this 1 6 to a single figure. 1 plus 6 is 7. We go ahead with this 7. 7 plus 6 is 4, 1 3, or 1-1-3-4. For plus 5 is 9, forget it. For plus 2 is 6. Forget 9. Proceeding this way, we get the digit sum equal to 7. For decimals, we work exactly the same way, but we don't pay any attention to the decimal point. The digit sum of 6.256, for example, ISI. Note, it is not necessary in a practical sense to understand why the method works, but you will see how interesting this is. The basic fact is that the reduced digit sum is the same as their remainder when the number is divided by 9. For example, digit dash the sum of 523 is 1. And also when 523 is divided by 9, we get the remainder 1. Checking of calculation basic rule. Whatever we do to the numbers, we also do to their digit sum. Then the result that we get from the digit sum of the numbers must be equal to the digit sum of the answer. For example, the number 23 plus 49 plus 15 plus 30 is equal to 117. The digit sum 5 plus 4 plus 6 plus 3 is equal to 0, which reduces to 0 is equal to 0. This rule is also applicable to subtraction, multiplication, and up to some extent to division also. These will be discussed in the coming chapters. We should take another example of addition. Addition 7 1.5 plus 32.5 plus 23.9 is equal to 57.9. Digit sum 6 plus 1 plus 5 is equal to 3, or 3 is equal to 3. Thus, if we get LHS equals RHS, we may conclude that our calculation is correct. Sample question. Check for all the calculations done in this chapter. Note, suppose two students are 6 given to solve the following question. 1.5 plus 32.5 plus 23.9 equals? One of them gets the solution as 57.9. Another student gets the answer 48.9. If they check their calculation by this method, both of them get it to be correct. Thus, this method is not always fruitful. If our luck is against us, we may approve our wrong answer also. Addition of mixed numbers QTA 141, 4 to 1. 9 underscore equals 9 squared 5 3 solution. A conventional method for solving this question is by converting jack of the numbers into pure fractional numbers first, and then taking the LCM OL denominators. To save time, we should add the whole numbers and the fractional values separately. Like here, for 1 N4 O3 caret plus 4 F9, M3 plus 4 plus 9, F plus equals 16.1 caret 30 32 to the power of J caret 3 equals N6 plus 1, T 30 Q5 dash 2 dash 4 dash 2F LL 3644 Soln 5 to 4 plus 2 to 1. IJ 930 17 1930 213 underscore L 3644 to 2 1. 8 minus 2 plus 9 minus 3 to the power of 112 2 plus 11 squared plus 1 minus 3. Warning. Empty page. Multiplication special cases, we suggest you to remember the tables up to 30 because it saves some valuable time during calculation. Multiplication should be well commanded because it is needed in almost every question of our concern. Let us look at the case of multiplication by a number more than 10. Multiplication by 11. Step by. The last digit of the multiplicand, number multiplied, is put down as the right-hand figure of the answer. Step 2. Each successive digit of the multiplicand is added to its neighbor at the right. XL. Solve 5892 by 1 equals? Soln. Step by. Put down the last figure of 5892 as the right-hand figure of the answer 5892 by 112. Step 11. Each successive figure of 5892 is added to its right-hand neighbor. 9 plus 2 is 1. Put 1 below the line and carry over 1. 8 plus 9 plus 1 is 18. Put 8 below the line and carry over 1. 5 plus 8 plus 1 is 14. Put 4 below the line and carry over 1. 5892 by 1112. 9 plus 2 is equal to 11. Put 1 below the line and carry over 1. 5892 by 1812. 8 plus 9 plus 1 is equal to 18. Pull 8 below the line and carry over 1. 5892 by 114,812. 5 plus 8 plus 1 is equal to 14. Put 4 below the line and carry over 1. Step 3. The first figure of 5,892, 5 plus 1, becomes the left-hand figure of the answer. 5892 by 1164812. The answer is 64,812. 10 quicker maths. As you see, each figure of the long number is used twice. It is first used as a number, and then at the next step, it is used as a neighbor. Looking carefully, we can use just one rule instead of 3 rules. And this only rule can be called as add the right neighbor rule. We must first write a 0 in front of the given number, or at least imagine a 0 there. We apply the idea of adding the neighbor to every figure of the given number in turn. 05892x12, as there is no neighbor on the right, so we add nothing. 05892x114812, as WC did earlier. 05892x11648,120 plus 5 plus carried over 1 is 6. This example shows why we need the 0 in front of the multiplicand. It is to remind us not to stop too soon. Without the 0 in front, we might have neglected the last 6, and WC might then have thought that the answer was only 4,812. The answer is longer than the given number by 1 digit, and the 0 in front takes care of that. Sample problems. Solve the following. 1111111 x 11 23,145 x 11 89067 x 11 5776800 x 11 1122332608 x 11 ans 1122 22212 2545953 9797374 635448005 1234 565 8688. Multiplication by 12. To multiply any number by 1, 2, we double each digit in turn and add its neighbor. This is the same as multiplying by 1, 1, except that now we double the number before we add its neighbor. For example, x1, solve. 5324 by 12 solve. Step 1. 05324x 8. Double the right-hand figure and add 0, as there is no neighbor. Multiplication 11. Step N. 05324x 1288. Double the 2 and add 4. Step 111. 05324x 12888. Double the 3 and add 2. Step 4. 05324x 123888. Double the 5 and add 3. Equals 13. Put 3 below the line and carry over 1. Last step. 05324x 1263,888. 0 doubled is 0. Plus 5 plus carried over 1. The answer is 63,888. If you go through it yourself, you will find that the calculation goes very fast and is very easy. Practice question. Solve the following. 1. 35609x 122. 111230009x 4567889x 124. 2220007x 444890711x 12 ans 1 4273082 13347611083 5481464 266400845 533 868 8532. Multiplication by 13. To multiply any number by 13, we treble each digit in turn and add its right neighbor. This is the same as multiplying by 12, except that now we treble the number before we add its neighbor. If we want to multiply 9,483 by 13, WC proceed like this. Step I. 09483x 139. Treble the right-hand figure and write it down as there is no neighbor on the right. Step 2. 09483x 1379. 8 times 3 plus 3 is equal to 27. Write down 7 and carry over 2. Step 3. 0.9483 13 279, 4 by 3 1 to the power of 8 plus 2 minus 22, W write down 2, and carry over 2, step 4. 0.9483 13 3279, 9 times 3 plus 4 plus 2 is equal to 33, write down 3, and carry over 3. Last step. 0.9483 13 123,279, 0 times 3 plus 9 plus 3 is equal to 12. Write it down. The answer is 1, 23, 279. 12 quicker maths in a similar way. We can define rules for multiplication by, but during these multiplications we will have to get 4 or 5 times alpha digit, which is sometimes not so easy to carry over. We have an easier method of multiplication for those large values. Can you get similar methods for multiplication by 21 and 31? It is not very tough to define the rules.
Try it.
Multiplication by 9. Step 1. Subtract the right-hand figure of the long number from 10. This gives the right-hand figure of the answer. Step 2. Taking the next digit from right, subtract it from 9, and add the neighbor on its right. Step 3. At the last step, when you are under the 0 in front of the long number, subtract 1 from the neighbor and use that as the left-hand figure of the answer. x1. 8,570. 6 times 9 is equal to? Son. 0.8576 x 9 77,184. Step 1. Subtract the 6 of 8,576 from 10, and we have 4 of the answer. Step 11. Subtract the 7 from 9, we have 2, and add the neighbor 6. The result is 8. Step 111. Open parenthesis 9 minus 5 close parenthesis plus 7 is equal to 1. Put 1 under the line and carry over 1. Step 4. 9 to 8 plus 5 plus L carried over equals 7. Put it down. Step V. Last step. We are under the left-hand 0, so we reduce the left-hand figure of 8,576 by 1, and 7 is the left-hand figure of the answer. Thus, answer is 77,184. Here are a few questions for you. 1. 34x9 equals? 2. 569x9? 3. 1,328 times 9 is equal to 4. 56493x9 equals? 5. 8927325 equals? Answers 1. 3062, 5121 3, 11,952 4, 5084 80345932. We don't suggest you to give much emphasis on this rule, because it is not very much easy to use. Sometimes it proves very lengthy also. Another method. Step 1. Put a 0 at the right end of the number, i.e., write 85760 for 8576. Step 11. Subtract the original number from that number, like 85,760 minus 8,576 is equal to 77,184. Multiplication 13. Multiplication by 25. Suppose you are given a large number like 12s 6902s8, and someone asks you to multiply that number by 25. What will you do? Probably you will do nothing but go for simple multiplication. Now, we suggest you to multiply that number by 100 and then divide by 4. To do so, remember the 2 steps. Step I. Put 2 zeros at the right of the number, as it has to be multiplied by 100. Step L. Divide the number by 4. So your answer is 12569025800 equals 314,225,6450. Is it easier than your method? 10 base method of multiplication. This method can best be explained with the help of different examples. x1. Suppose we have to multiply 9 by 8. Son. Step I. We should take, as base for our calculations, that power of 10 which is nearest to the numbers to be multiplied. In this case, 10 itself should be our base. Step 2. Put the two numbers 9 and 8 above and below on the left-hand side. Step 111. Subtract each of them from the base, 10, and write down the remainders, 1 and 2, on the right-hand side with minus symbol, sign before them. Step 4. The product will have two parts, one on the left side and one on the right. A vertical dividing line may be drawn for the purpose of demarcation of the two parts. Step V. Cross-subtract the deficiency 2 in the second row from the original number 9 in the first row. 9 minus 2 is equal to 7, or cross-subtract in the converse way, i.e., 1 from 8. And we get 8 minus 1 is equal to 7, the same. This is our left-hand side portion of the required I answer. Step 6. Now, vertically multiply the two deficit figures, 1 and 2. The product is 2. And this is the right-hand side portion of the answer. We can SEC the method diagrammatically. 9 to 1 8 minus 2/2, thus the answer is 72. 14 quicker maths. This method holds good in all cases and is, therefore, capable of infinite applications. As further illustration of the same rule, note the following examples. 9 minus 1 9 minus 1 9 minus 1 8 minus 2 8 minus 2 7 minus 3 9 minus 1 7 minus 3 6 minus 4 8 minus 2 7 minus 3 7 minus 3 8/1 and 6/3 5/4 6/4 5/6 4/9. Note. On the right-hand side portion of the answer there should be as many digits as denoted by the power on our base, 10. In all one of the above cases our base is 10, which is equal to low. Thus in all of the above examples we have only one digit on the right-hand side of the answer. But what happens when the multiplication of deficit digits yields a product consisting of more than one digit? For example, when we have to multiply 7 by 6. 7 minus 3 6 minus 4 3/I2. This difficulty, however, is easily surmounted with the usual multiplication rule that the surplus portion of the right should always be carried over to the left. Therefore, in the present case, we keep the 2 of the 12, minus 3 greater than minus 4 equals 12, on the right-hand side and carry the 1 over to the left and change 3 into 4. We thus obtain 42 as the actual product of 7 and 6. 7 minus 3 6 minus 4 and 4 halves. In all the above cases, the multiplicand and the multiplier are just a little below the base 10. What about the numbers which are above it? Exodus 2 verse 12 x 1 1 equals Psalm 12 plus 2 11 plus 1 and 13 halves. Multiplication 15. Same procedure will hold good here too, except that, instead of cross-subtraction, we shall have to do cross-addition. And all the other rules regarding digit surplus, digit deficit, etc. will be exactly the same as before. x3. Solve. 16 times 11 is equal to 18 times 12 is equal to 19x 13 equals 7, 17x 17 equals 12 times 13 is equal to Psalm 16 plus 6 18 plus 8 19 plus 9 11 plus 1 12 plus 2 13 plus 3 17 divided by 6 is equal to 176 20/I6 equals 216 22 divided by 27 is equal to 247. Solve rest of the questions. When one of the numbers is above asterisk the base and the other is below the base, 10x4. Solve. 12 times 9 is equal to Psalm 12 plus 2 9 minus 1 and 11 halves equals 10 8 plus and minus will, on multiplication, produce a minus productant that the NGHT hand portion obtained by vertical multiplication will therefore have to be subtracted. Thus, 1 right-hand portion of the answer is subtracted from 10. U left-hand portion of the answer is reduced by 1. x5. Soiv. 14 times 6 is equal to Psalm 14 plus 4 6 minus 4 is equal to 10/T6 equals 9 6 equals 84. Right-hand portion yields minus 16. By the established rule, as we did earlier, 1 should be subtracted from 1 0. In the second stage, we operate in the same manner as in X4. After a good practice, these methods of calculation can be done mentally. So, the readers are suggested to go through every step carefully and have a good practice with all types of questions. Practice questions solve the following: 1. 12x11 2, 13 by 12 3, 14x 7 4, 11x 6 5, 17x 13 6, 19x 15 7, 18x 8. 16 Quicker Maths Answers 1. 132 2, 156 3, 98 4, 66 5, 221 6, 285 7, 144. When the multiplicands and multipliers are nearer to 100, our base should be 100, 10 carat. In that case, the right-hand portion of the answer should have 2 digits. And the other rules are the same. X6 solve. 1. 91 times 96 is equal to 2. 99 times 98 is equal to Solm sad face L. 91 minus 9, 2, 99 minus 196 minus 498 minus 2 and 8736 equals 8730, 697 slash 02 equals 9702 x7, solve. 1. 93 times 92 is equal to 2. 93 times 93 is equal to 3. 97 times 96 is equal to 4. 89 times 85 is equal to Solm sad face L. 93 minus 7, 2. 93 minus 7, 3. 97 minus 3, 92 minus 8, 93 minus 7, 96 minus 4 and 85 56, 86 slash 49. 93 divided by 12 is equal to 8,556 equals 8,649 equals 9,312. Solve question for yourself. X8. Solve. 1. 102 times 89 is equal to 2. 105 times 92 is equal to 3. 107 times 91 is equal to 4. 115 times 92 is equal to Solm. 1. 102 plus 2. 2. 105 plus 5 98 minus 2 92 minus 8 100 slash 04 equals 9,990. 697 divided by 40 is equal to 9,660. Solve other questions yourself. Note. When right-hand side of the answer is negative, it is subtracted from 100 and left-hand side is reduced by 1. X9. Solve. 1. 102 times 103 is equal to 2. 105 times 107 is equal to 3. 111 times 117 is equal to 4. 115 times 108 is equal to Solm sad face L. 102 plus 2. 2. 105 plus 5 103 plus 3 107 plus 7 105 slash 06 equals 10,506. 112 divided by 35 is equal to 11,235. 3. 111 plus 11,117 plus 17,128 slash 87 equals 12,987. Solve question for yourself. Multiplication 17x 10. Solve. 1. 998 times 981 is equal to 2. 978 times 983 is equal to 3. 112 times 995 is equal to 4. 1118 times 985 is equal to 5. 1107 times 1113 is equal to carat in. Our base should be 1,000, 10 carat. Thus, the right-hand portion of the answer should be of 3 digits. 1. 998 minus 2. 2. 978 minus 22,981 minus 19,983 to 17,979 slash 038 equals 979,038%. 1 slash 374 is equal to 961,374. 3. 1112 plus 112,995 to 5. 1107/560 equals 110. 6440. Solve other questions yourself. Multiples and submultiples in all the above cases. We had both the multiplicand and the multiplier, or at least one of them, very near the base, and they gave a small remainder and thus rendered the multiplication very easy. What about the multiplication of two numbers, neither of which is near to a convenient base? In that case, we take a convenient multiple or submultiple off a suitable base as our working base, perform the necessary operation with its aid, and then multiply or divide the result proportionately. Suppose we have to multiply 47 by 49. Both these numbers are so far away from the base 10 or 100. If we take either of the two as our base, the sufficiency or deficiency are so large that their multiplication would create a new problem equally tough. We, therefore, accept 100 merely as a theoretical base and take submultiple 50, which is convenient occur both 47 and 49, as our working base. 47. 349 to 12. 46/03 equals 2303. Step I. We take 50 as our working base. Step 2. By cross-subtraction, we get 46 on left-hand side. Step 3. As our working base is derived from 100, the right-hand side caret will have 2 digits. Step 4. As 50 is a half of 100, therefore, divide 46 by 2 and put 23 down as the real left-hand portion of the answer. Step V. The right-hand portion 3 remains unaffected. 18 quicker maths or. Instead of taking 100 as our theoretical base and its half, SO, as our working base, we may take 10 as our theoretical base and its multiple, so, as our working base, and ultimately multiply the left-hand portion by S. 47 minus 349 to 1 SX 46/3 230 divided by 3 is equal to 2303. Right-hand portion will be off single digit. Why? Because our base is 10 star. Can you solve the above question by taking 10 as your theoretical base and 40 as working base? X2. Solve. 1. 48 times 49 is equal to 7. 2. 47x 46 equals 7. 2. Solve. 1. Working base equals y equals 50. 48 minus 249 to 1 2. 47/02 equals 23j/02 equals 23. 50 seconds equals 2352. Here 47 is odd. Its division by 2 gives a fractional quotient 23 caret, and just as half an IP is taken over to the right-hand side, so the half here in the 23 caret is taken over to the right-hand side as 50. Solve the other question. General rule for multiplication, having dealt in fairly sufficient detail with the application of special cases of multiplication. We now proceed to deal with the general formula applicable to all cases of multiplication.
It is sometimes not very convenient to keep all the above cases and their steps in mind.
It is sometimes not very convenient to keep all the above cases and their steps in mind, so all of us should be very much familiar with general formula of multiplication. Multiplication by a two-digit number x. I solve. 1. 12 times 13 is equal to 7. 2. 17 times 18 is equal to 7. 3. 87 times 92 is equal to 7. Soln wink with a frown L. 12 times 13 is equal to 7. 19. Step 1. Multiply the right-hand digits of multiplicand and multiplier, unit digit of multiplicand with unit digit of the multiplier. 121136, 2 by 3, step 5. Now, do cross-multiplication, i.e., multiply 3 by 1 and 1 by 2. Add the two products and write down to the left of 6. 12x 1356, 3xl plus 2xl, step 3. In the last step, we multiply the left-hand figures of both multiplicand and multiplier. 121356, 1 by 1, 17I86, 7 times 8 is equal to 56. write down 6 and carry over 5. Step IL. 171806. 1 times 8 plus 7 times 1 plus 5 is equal to 20. Write down 0 and carry over 2. Step 111. 1718. 2. 17 times 18 is equal to? Step I. 306. 1 times 1 plus 2 is equal to 3. Write it down. 20 cute Sikara Megishas 3. 87x92 equals? Step L. 87924. 7 times 2 is equal to 14. Write down 4 and carry over 1. Step 2. 879204. 8 times 2 plus 9 times 7 plus 1 is equal to 80. Write down 0 and carry over 8. Step 3. 8792 8004. 8 times 9 plus 8 is equal to 80. Practice questions 1. 57x43 2. 51x42 3. 38x43 4. 56x92 5. 81x19 6. 23x99 7. 29x69 8. 62x71 9. 17x37 10. 97x89 answers 1. 2451 2. 2142 3. 1634 4. 5152 5. 1539 6. 2277 7. 2001 8. 44029. 629 10. 8630 3x2. Solve 1 3 25 by 1 7 equals 2. 4359 times 23 is equal to? Solve 1 step I. 325 I 75. 5 times 7 is equal to 35. Pull down 5 and carry over 3. Step 11. 325 by 1725. 2x7 plus 5xl plus 3 equals 22. Put down 2 8 can over 2. Step 111. 325 525. 3x7 plus 2xl plus 2 equals 25. Pull down 5 and carry over 2. Multiplication 21 note. Repeat the cross multiplication medial as the consecutive pairs of digits exhaust in step 11. We cross multiplied 25 and 17 and step HI. We cross multiplied 32 and 17. Step 4. 325 backslash 175525. 3 times 1 plus 2 is equal to 5. Put it down. 2. Step I. 4359237. 9 times 3 is equal to 27. Put down 7. Carry over 2. Step 11. 4 3 to the power of 92357. Step 3. Backslash IK. 5 times 3 plus 9 times 2 plus 2 is equal to 35. Put down 5 and carry over 3. 257. 3 times 3 plus 5 times 2 plus 3 is equal to 22. Put down 2. Carry over 2. Step 4. 4359 backslash 230257. 4 times 3 plus 3 times 2 plus 2 is equal to 20. Put down 0. Carry over 2. 22 Cricker Maths Step V. Caret 231000257. 4 times 2 plus 2 is equal to 10. Put it down. We can write all the steps together. 4359234x2 slash 4x3 plus 2x3 slash 3x3 plus 5x2 slash 5x3 plus 9x 27 9 times 3 is equal to 10 2 0 22 35 27 is equal to 100,257, or we can write the answer directly without writing the intermediate steps. The only thing we keep in mind is the carrying numbers. 4359 4359 23 or 2310 20 22 35 27 10 0 257. Note: you should tidy for this direct calculation. It saves a lot of time. It is a very systematic calculation and is very easy to remember. Watch the above steps again and again until you get that systematic pattern of cross multiplication. Multiplication by a 3-digit number x. 1. Solve 1. 321 times 132 is equal to 2. 4,562 times 345 is equal to 369,712x 641 equals Solm Sadfacel, Steppel. 32 1 times 2 is equal to 2, step 2. 321, x 72. 2x2 plus 3xl equals 7. Multiplication 23 step 3. 132 step 4. 372. 2x3 plus 3x2 plus lxl equals 13. Write down 3 and carry over 1. 321 by 1322 372. 3x3 plus 1x2 plus l equals 12. Write down 2 and carry over 1. Step V. 321 1324 372. 1 times 341 is equal to 4. Or 321 13293. 3x3 plus lx2 slash 2x3 plus 3x2 plus lxl slash 2x2 plus 3xl slash 1 times 2 is equal to 4. 2l372 is equal to 42,372. 2. 4 5 6 2 3 45 4x3 slash 4x4 plus 3x5 slash 5x4 plus 4x5 plus 3x6 slash 5x5 plus 4x6 plus 3x27 5x6 plus 4x27 2 times 5 is equal to 1537 6 to 358 39. 0 equals 157 3890 3. 6971264 I6x674x640x971x 6 plus 4x940 6x77 1x9 plus 4x740 6x17 1x7 plus 4x14 caret x27 1 x1 plus 4x27 1 times 2 is equal to 44 86 88 45 23 92 equals 44. 685392. 24 quicker MATHS note. Did you get the clear concept of cross multiplication and carry hashtag ing cross multiplication? Did you mark how the digits in cross multiplication increase, remain constant, and then decrease? Take a sharp look at question 3. In the first row of the answer, if you move from right to left, you will see that there is only one multiplication 1 by 2 in the first part. In the second part there are 2, 1 by 1 and 4 by 2. In the third part 3, 1x7 for x1 and 6 by 2. In the fourth part 3, 1x9 for by 7 and 6x1. In the fifth part again 3, 1x6 for by 9 and 6 by 7. In the sixth part 2, 4 by 6 and 6 by 9, and in the last part only 1, 6 by 6, multiplication. The participation of digits in cross multiplication can be shown by the following diagrams. 1.69712 11.69712 111.69712 697 12 V.697 12,641,641 for each of the groups of figures. You have to cross multiply. Multiplication by a 4-digit number example. Solve 1. 4325x 3216 2. 646329x 8124 Soin. 1. 4325x 3216 equals? Step 1.43253216 0. Step 2. 4325, 3216. 5 times 6 is equal to 30. Write down 0 and carry over 3, 0, 0. 2 times 6 plus 1 times 5 plus 3 is equal to 20. Write down 0 and carry over 2, 2, 0, 0. 3 times 6 plus 2 times 1 plus 5 times 2 plus 2 is equal to 32. Write down 2 and carry over 3. Multiplication 25 Step 4. 4325f 3216 9200 Step V. 4325x 3216 0920 0 Step 6. 4325x 3216 4x6 plus 3xl plus 2x 2 plus 5x 3 plus 3 equals 49. Write down 9 and carry over 4. 4xl plus 3x2 plus 2x3 plus 4 equals 20. Write down 0 and carry over 2. 909200. 4 times 2 plus 3 times 3 plus 2 is equal to 19. Write down 9 and carry over 1. Step 7. 4 3 25 I 32 16 1 3 909,200. 4 times 3 plus 1 is equal to 13. Write it down. Ans. 139092002. 646329x80 equals? Try this question yourself and match your steps with the given diagrammatic presentation of participating digits. Step I, 646329. Step 2. 646329I8 124 8. Step 3. 6463 to the power of 9 8f. Step V. 646 94. 26 quicker maths. Step 7. 646 329 backslash 8124 8124. Step IX. 646 329 backslash 8124. Practice problems. Solve the following. 1. 234x456 336
1. 234x 456 2. 336x
1. 234 by 456 2, 336x 678 3, 872x 4314, 2345 by 67 5, 345,672x 456 6, 569 by 952 7, 458 by 9088, 541x 342 9, 666 by 444 10, 8103 by 451 1, 56321x 672 12. 1278 by 569 13, 5745x 562 14, 4465x 887 15.
1278 by 569 13, 5745x 562 14, 4465x 887 15, 8862x 341. Answers I. 1067042, 2278083, 3758324, 157,115 5, 1576264 541,688 7, 4158 185,022 9, 29570 410, 3646 3502. 3784771 72718 322869 39604555 302194. Checking of multiplication Excel. 15 times 13 is equal to 195 digit sum. 6 times 4 is equal to 6 or 24 is equal to 6 or 6 is equal to 6. Thus, our calculation is correct. x2, 69712x 641 equals 44685 digit sum. 7x2 equals 5 or 14 is equal to 5 or 5 is equal to 5. Therefore, our calculation is correct. x3, 321 times 132 is equal to 42,372 digit sum. 6 times 6 is equal to 0 or 36 is equal to 0 or 0 is equal to 0. Thus, our calculation is correct. But if someone gets the answer 43,227 and tries to check his calculation with the help of digit sum rule, see what happens. 321 times 132 is equal to 43,227 digit sum. 6 times 6 is equal to 0 or 36 is equal to 0 or 0 is equal to 0. This shows that our answer is correct. But it is not true. Thus we see that I4 luck is very bad. We can opt over our wrong answer. Division. We now go on to tie quicker maths of AFCAT division, which is based on long-established Vedic process of mathematical calculations. Different fix M for the special cases. It is capable of immediate application to all cases, and it can be described as the crowning gem OFAL for the universality of its applications. To understand the at-sight mental one-line method of division, we should take an example and its explanation. Division by a two-digit number x1. Divide 38982 by 73. Soln, step I. Out of the divisor 73, we put down only the first digit, i.e. 7 in the divisor column, and put the other digit, i.e. 3 on top of the flag, as shown in the chart below. 73898 to the entire division will be by 7. Step 2. As one digit, 3, has been put on top, we allot one place at the right end of the dividend to the remainder position of the answer and mark it off from the digits by a vertical line. 7 to the power of 3898 to step 3. As the first digit from the left-off dividend, t, is less than 7, we take 38 as our first dividend. When we divide 38 by 7, we get s as the quotient and 3 as the remainder. We put 5 down as the first quotient digit and just prefix the remainder 3 before the 9 of the dividend.
C'est à la puissance J38398.
215 are step 4. Now our dividend is 39. From this we, however, deduct die product of the index 3 and die first quotient digit, s, i.e. 3 times 5 is equal to is. The remainder 24 is our actual net dividend. It is then divided by 7 and gives us 3 as die second quotient digit and 3 as 28 quicker maths the remainder, to be placed in their respective places, as was done in third step. 7 to the power of 38 39 38 2. 5 step V. Now our dividend is 38. From this we subtract the product of the index, 3, and the second quotient digit, 3, i.e. 3 times 3 is equal to 9. The remainder 29 is our next actual dividend and divide that by 7. We get 4 as the quotient and 1 as the remainder. We put them at their respective places. 7 to the power of 38 39 38 I 2 5 3 4 step 6. Our next dividend is 12, from which, as before, we deduct 3 by for the third quotient digit, i.e. 12, and obtain 0 and the remainder 7 to the power of 38 39 38 L 2 5 3 4 0. Thus we say quotient Q is 534 and remainder R is 0. And thus finishes the whole procedure, and all of it is one-line mental arithmetic in which all the actual division is done by Thiessen-Gleditsch divisor 7. Lie procedure is very simple and needs no further exposition and explanation. A few more illustrations with running comments will be found useful and helpful and are therefore given below. x2. Divide 16,384 by 128, as 12 is a small number to handle with. We solve. 12 8 16 43 118 60 4 1 2 8 0 step I. We divide 16 by 12. Q equals 1 and R equals 4. Step 2. 43 minus 8 times 1 is equal to 35 is our next dividend. Dividing it by 12, Q equals 2, R equals 11. Step 3. 118 minus 8 times 2 is equal to 102 is our next dividend. Dividing it by 12, Q equals 8, R equals 6. Step 4. 64 minus 8 times 8 is equal to 0, then our final quotient equals 128 and remainder equals 0. Division 29 fexs, stitai. Divide 6013. 7m 25 by 76. 6111, 63. 22 25 7 9 12 13 equals 25-6x2 CQ1. Here, in the end s.t division by 7, we can pot 8 down as the first quotient die, but the remainder then left will be too small for the subtraction expected at the next step. So, we t to the power of e7 as the quotient digit and prefix the remainder 1 to the next dividend digit. All the other steps are similar to the previously Mentemide steps in x1 and 2. Our final quotient is 7,912 and remainder is 13. If we want the values in decimal, we go on dividing as per rule instead of writing down the remainder, such as 76, 61, 325, 65, 0791, 2171, ANS equals 7,912.171. Note: IE vertical line separating the remainder from the quotient part may be the demarcating point for decimal. Psalm 3 by 7 L7 J L7 57 77 87 77 20 4 6 7 8 13 equals 77, 8 by 8. Q equals 204,678. R equals 13. You must go through all the steps of the above solution.
Try to solve it.
Did you find some difference? X5. Divide 899,7654 by 99.
Try it step by step.
X6. 1. Divide 710.014 by 39 to 4 places of decimals. 2. 718.589 carat 23 equals 3. 718.589 carat 96 equals
Carat in.
1. Since there is one hag digit, the vertical line is drawn such that line digit before the decimal comes under remainder portion. 3 foot 7 4 L I 80.
22 litres 64 70 à 8054.
30 quicker maths for the last section. We had 64 minus 45 is equal to 19 as our dividend. Divided by 3, we choose 4 as our suitable quotient. If we take s as a quotient, it leaves 4 as remainder, 19 to 15. Now the NWCD dividend will be 40 minus 9 times 5 is equal to minus 5, which is not acceptable. The vertical line separating the remainder from quotient part may be demarcation point for decimal.
Therefore, en égale 18.2054, H, livre sterling J 7 îlot 8. I5 I8 au 9 1.
Therefore, en égale 18.2054,
Therefore, ANS equals 18.2054, H, pound J7 IL08. I5 I8091 AN.
Therefore, en égale 18.2054, H, livre sterling J 7 îlot 8. I5 I8 au 9 1.
Therefore, ANS equals 18.2054, H, pound J7 IL08. I5 I8091 ANS equals 31.243312430, 3, 9 registered trademark 7188. I05 98592020 ANS equals 7.4853748530 divide 7.3 by 5, Soln 57. 23506404013773 ANS equals 0.137736 division by a 3-digit number x8, divide 7031985 by 823. Soln, step I. Here the divisor is OF 3 digits. All the difference which we make is to put the last 2 digits, 23, of divisor on top. As there are 2 flag digits, 23, we will separate 2 digits, 85, for remainder. 87319 I85 Step 2. We divide 70 by 8 and put down 8 and 6 in their proper places. 823 70 63 19 85 8 Step 3. Now, our gross dividend is 63. From that we subtract 16, the product of the tens of the flag digits, i.e. 2, and the first quotient digit.
From that we subtract 16, the product of the tens of the flag digits, i.e. 2, and the first quotient digit, i.e. 28 quicker maths the remainder, to be placed in their respective places, as was done in third step. 7 to the power of 38, 39. 30 quicker maths for the last section. We had 64 minus 45 is equal to 19 as our dividend. Divided by 3 we choose 4 as our suitable quotient. If we take s as a quotient, it leaves 4 as remainder, 19 to 15. Now the NWCD dividend will be 40 minus 9 times 5 is equal to minus 5, which is not acceptable. The vertical line separating the remainder from quotient part may be demarcation point for decimal.
Therefore, en égale 18.2054, H, livres sterling J 7 îlot 8. I5 I8 au 9 1 an égale 3243 31 2430 II, 9 symbole marque déposée 7188.
IO 598592020 ANS equals 7.48537485302x7, divides 7.3 by 5, Soln, 57. 23506404013776 ANS equals 0.137736 division by a 3-digit number x8, divides 7031985 by 823. Soln, step I. Here the divisor is of 3 digits. All the difference which we make is to put the last 2 digits, 23, of divisor on top. As there are 2 flag digits, 23, we will separate 2 digits, 85, for remainder. 870, 319 I 85 step 2. We divide 70 by 8 and put down 8 and 6 in their proper places. 8 23 70 60 319 85 8 step 3. Now, our gross dividend is 63. From that we subtract 16, the product of the tens of the flag digits, i.e. 2, and the first quotient digit, i.e. 8, and get the remainder 63 minus 16 is equal to 47 as the actual dividend. And, dividing it by 8, we have 5 and 7 as Q and R respectively, and put them at their proper places. Division 31 8 cubed 70 63 7 I 9 85 8 5 STQ 4. Now our gross dividend is 71, and we deduct the cross products of 2 flag digits 23 and the 2 quotient digits 8 and 5. i.e. 2 times 5 plus 3 times 8 is equal to 10 plus 24 is equal to 34, and our remainder is 71 minus 34 is equal to 37. We then continue to divide 37 by 8. We get Q equals 4 and R equals 5 8 70 60 3 7 L 59 85 8 5 4 step V. Now our gross dividend is 59. And actual dividend is equal to 59 minus cross product of 23 and 54, i.e. 59. 2x4 plus 3x5 equals 59 minus 23 is equal to 36. Dividing 36 by 8, R0 is equal to 4 and R equals 4. 8 happy face, 70 63 7 L S9 I 4 85 8 5 4 4 step 6. Actual dividend equals 48 minus open parenthesis, 3 times 4 plus 2 times 4 close parenthesis is equal to 48. 20 is equal to 28. Dividing it by 8, RQ equals 3 and R equals 4 8 to the power of 70 63 7 L 59 4845 5 4 41 step 7. Actual dividend equals 45. 3x4 plus 2x3 equals 45 minus 18 is equal to 27. Dividing 27 by 8, we have Q equals 3 and R equals 3. 8 happy face 70 63 7 I 59 4 8 4 5 3 8 5 4 4 3 3. The vertical line separating the remainder from the quotient part may be a demarcation point for decimal. ANS equals 8,544.33. Our answer can be 8,544.33, but if we want the quotient and remainder, the procedure is somewhat different. In that case, we do not need the last 2 steps, i.e., the calculation up to the stage 8 to the power of 170 63 7 L 59 148 5 8 5 4 4. 32 quicker maths is sufficient to answer the question. Quotient equals 8,544, remainder equals 485, 10x, cross multiplication of 23 and 44, asterisk, unit digit of flagged number x unit digit of quotient, equals 485-10, 4x, 2 plus 4 by 3. 3x4 equals 485 minus 200 minus 12 is equal to 273 asterisk cross multiplication of the two flag digits and last two digits of quotient. x9. Divide 1064321 by 743 to 4 places of decimals. Also find the remainder. Seln 74310 36 44 43 52 114320 is equal to 1432. Remainder equals 521 to 10. Cross multiplication of 43 and 32. 3 times 2 is equal to 521. 10 times 17 minus 6 is equal to 345 for decimals. 7-inch asterisk caret 10 36 44 43 5271 706 05 01432 I 4643 ANS equals 1432.4643 x 10. Divide 888 by 672 to 4 places of decimals. 6 8 28 38 304 05 L 32 14 ANS equals 1. 32 I4 note. Vertical lines separating the remainder from the quotient part is the demarcation point for decimal. Can you find the quotient and remainder?
T.T. Wyatt.
x11. Divide 4213 by 1234 to 4 places of decimals. Also find quotient and remainder. Soln. Although 1234 is a 4-digit number, we can treat it as a 3-digit number because 12 is small enough to handle with. 12 happy face I 42 613 3. Division 33 Q equals 3. R equals 613 to 10. Cross multiplication of 0, 3 and 34. 4x3 equals 613 minus 90 minus 12 is equal to 511 12 34 42 6 L 43 7 0 3 0 2 3 4 14 1 ANS equals 3.4141 division by a 4-digit number x12. Divide 703195 by 823 1. Soln. As there are 3 flag digits, 3 digits are separated by vertical line. G23 L 70 63 7 I 59 45 6 85 432 answer equals 85.432 step I. First dividend equals 70, Q equals 8, R equals 6 step 2. Second real D, idend equals 63 minus 16 is equal to 2 times 8 equals 47, Q equals 5, R equals 7 step 3. Third real dividend equals 71. Cross multiplication CM of 23 and 85 is equal to 34, equals 37, Q equals 4, R equals 5 step 4. Fourth real dividend equals 59, CM of 231 and 854 equals 59, 1 by 8 plus 3 by 5 plus 2 by 4 equals 59, 31 is equal to 28, Q equals 3, R equals 4 step V. Fifth real dividend equals 45, CM of 231 and 543 equals 45 dash 1 by 5 plus 3 by 4 plus 2 by 3 equals 45 dash 23 equals 22, Q equals 2, R equals 6, but if we want to get the quotient and the remainder, do the following. 8 23. 70 63 70 195 85 Q equals 85 R equals 70 195 minus 100 CM of 231 and 0 85 10 CM of 31 and 85 1 times 5 is equal to 7,195 3,400 minus 230 minus 5 is equal to 7,195 3,635 is equal to 3,560 x 13. Divide 41326 by 31046 to 5 decimal places. 34 quicker maths Soln 1 I3 I2 26 40 I3 3112. ANS 1.33112 step I. First real dividend 4, Q equals 1. R equals 1. Step 11. Second real dividend, 11-1x1, 10, Q equals 3, R1. Step 3. Third real dividend equals 13, CM of 10 and 13, 13, Ox1T-X3, equals 10, Q equals 3, R1. Step 4. Fourth real dividend, 12, MV1.
All, 104-133, 12-7.
Third real dividend equals 13, CM of 10 and 13, 13, Ox1T-X3, equals 10 Q equals 3. R. 1. Step 4. Fourth real dividend, 12, MV1 OL 104 and 133, minus 12 to 7, 5. Q, 1 R2 step V5 LH real dib /.
Third real dividend equals 13, CM of 10 and 13, 13, Ox1T-X3, equals 10, Q equals 3, R1. Step 4. Fourth real dividend, 12, MV1.
All, 104-133, 12-7, 5 Ki, 1, R2 step 5 Alharil diiden, 26, JM.
Of 1046 and 133-1 equals 26, 19-7, R invenient Q equals 1, R equals 4 step \L, sixth real D \idend 40, CM of 1046 and 33-1, 40 minus 31 is equal to 9, convenient Q equals 2, R to the power of 4.
Note, LCM.
See Ross multiplication 2, CM that on 046 and 1331, 6xu4a3h, x3flx1 minus 19 soln, 1 happy face caret, happy face 20306L849144544.
En 0.14544.
Phi method is similar in this case also. He only remarkable PV in is that since there are 5 digits in Hag number, all the live digits of the dividend come in remainder section. X15. Divide 8905 BV769315 to 4 decimal places soln, caret 6931508 bo low 50115 anise. 0.0115. It is better to calculate up to s decimal places if you are asked to calculate up to 4 places, because without doing so we can't conclude that the further valid calculations exist. The dividend has only 4 digits, so we put a icro before 8 to make the number of digits equal to that in tlag number, 693-1s. During calculation, this 0 is copied down and doesn't participate in any type-off calculation. X16. Divide 0.0034147 by 81.42563321 to 6 decimal places. Soln. Change die Fotmoff number because di's fon may puzzle you over the placement off decimal. Division 35. Divide 34147 by 8142563321. Shifted the decimal to 7 position right. Now, G142563210033421945700000419 ANS equals 0.0000041 step I. Put 3 zeros before the number in the remainder section because there are 8 flagged digits. Step N. Copy down all the 3 zeros. Step 3. 3 is less than 8. In usual CASES, we have been taking first 2 digits at a time when first digit was less than the prime divisor, but as in this case we are after decimal, we can't do so. Therefore, in this case, 3FS treated as the first dividend, and we get Q equals 0 and R equals 3. Further, we proceed in the same way as discussed earlier. Now you must have seen all the possible cases which you may come across in mathematical division. Don't escape any of the examples discussed said above. Having a broad idea of at-sight mathematical division, you should solve as many questions yourself as you can. Checking of calculation, we will check the calculations of first 7 examples given in the beginning of this chapter. It can be seen that rule of digit sum fails in some cases here. X1. 38,982 T73 is equal to 534, since remainder is 0. Digit sum 3 4 minus 1 is equal to 3 or 3 is equal to 3 a Haripur. Our calculation is correct. X2, check yourself. X3, 60132547 76 gives quotient equals 7,912 and remainder 13. We may write the above calculation as 7,912 times 76 plus 13 is equal to 601,325 now. Check the correctness. Digit sum. 1 times 4 plus 4 is equal to 8 or 4 plus 4 is equal to 8 or 8 is equal to 8 therefore. Our calculation is correct. E*4, check yourself. I to the power of x5, check yourself x6. 1710.0144 minus 39 is equal to 18.2054. We can I the digit sum method to check our calculation because our calculation is not complete. 36 quicker MATHC 718.589 plus 23 is equal to 31.2430. This calculation is complete because in the end we get 0 as quotient and remainder. We can apply the digit sum rule in this case. Digit sum equals 2 plus 5 is equal to 4 or 0.4 is equal to 4 or 4 is equal to 4. Our calculation is correct. Note, during digit sum FOI-ET9 method, we don't take decimals into account. X7. Tell whether digit sum rule is applicable to this calculation or not. Note. Thus, we see the limitation of digit sum rule. Practice problems QL. Divide X by Y, where X igual a L 3592.1 y igual a 89b, X igual a 649.32 y igual a 99c, X igual a 88.99 y igual a 101d, X igual a 99.95 y igual a 122c, X igual a 1359.62.89 y igual a 76.0 asterisco igual a 89.325 y igual a 132 gramos, X igual a 89 y igual a 71h, X igual a 96 y igual a 95 y X igual a 50.
Divide x by y where a, x equals L 3592.1 and y equals 89b, x equals 64932 and y equals 99c. X equals 88.99 and y equals 101d, x equals 99.95 and y equals 122e, x equals 13596.289 and y equals 760 asterisk equals 89,325 and y equals 132 grams, x equals 89 and y equals 71h, x equals 96 and y equals 95i. X equals 53 and y equals 83j. X equals 93 and y equals 1092 quetzales. Divide x by y where a, x equals 35,928.1 and y equals 567b, x equals 8,932 and y equals 98.1c, x equals 99,899 and y equals 789d. X equals 1053 and y equals 989e, x equals 738 and y equals 895 0 x equals 13,569 and y equals 1051 grams, x equals 69325 and y equals 1163h, x equals 935 and y equals 1259i. X equals 100,002 and y equals 777j, x equals 12,345 and y equals 567 3 quetzales. Divide x by y where a, x equals 396,256 and y equals 6,539b, x equals 698,956 and y equals 5,783c, x equals 8,889 and y equals 6,798d, x equals 889 and y 9,834e, x equals 0.00532 and y 89.325 168f. backslash equals 0.056 and y equals 0.893 grams, x equals 12 and y equals 998,563 h. X equals 0.867 and y equals 93.834516 I. X equals 1.932 and y equals 105.63513 j. X equals 0.00035 and y 78.53 answers 1. A. 1527.2022 b. 655.87878 c. 88.10891 d. 81.926229 e. 178,898.539 f. 676.7045 grams, 1.2535 h, 1.0105 I, 0.6385 j, 0.85322. A. 633.6525 b, 9.1049 c, 126.6147 d, 1.0647 e, 0.8245 f, 12.9105 grams, 59.6087 h and gt 0.7426 I, 128.7027 j, 21.77243. A. 605.7892 b, 120.8639 c, 1.30759 d, 0.0904 e, 0.00005950 grams, 0.000012 h, 0.00923996 I, 0.01828993 j, 0.000044. Divisibility. We now take up the interesting question as to how one can determine whether a certain given number, however large it may be, is divisible by a certain given divisor. There is no defined general rule for checking the divisibility. For different divisors, the miles differ at large. We will discuss the rule for divisors from 2 to 19. Divisibility by 2, i.e., any number, the last digit of which is either even or 0, is divisible by 2. For example, 12, 86, 135, 68926 and 598, 3450 are divisible by 2, but 13,133 and 596,351 are not divisible by 2. Divisibility by 3 rule. If the sum of digits of a number is divisible by 3, the number is also divisible by 3. For example, 123, 2 plus 3 equals 6 is divisible by 3, hence 123 is also divisible by 3. 2. 5673, 5 plus 6 plus 7 plus 3 equals 21, therefore divisible by 3. 89,612, 8 plus 9 plus 6 plus 1 plus 2 equals 26 equals 2 plus 6 equals 8 is not divisible by 3, therefore, the number is not divisible by 3. Divisibility by 4 rule. If last two digits of a number is divisible by 4, the number is divisible by 4. The number having 2 or more zeros at the end is also divisible by 4. For example, 526,428, 28 is divisible by 4, therefore, the number is divisible by 4. 2. 5,300, here are 2 zeros at the end, so it is divisible by 4. 3. 134,000, as there are more than 2 zeros, the number is divisible by 4. 4. 134,522, as the last two-digit number, 22, is not divisible by 4, the number is not divisible by 4. Note, the same rule is applicable to check the divisibility by 25. That is, a number is divisible by 25 if its last two digits are either zeros or divisible by 25. 38 Quicker Maths. Divisibility by 5 rule. If a number ends in 5 or 0, IHE number is divisible by 5. For example, 1, 1345, as IL's last digit is 5, it is divisible by 5. 2. 1340, as its last digit is 0, it is divisible by 5. 3. 1343, as its last digit is neither 5 nor 0, it is not divisible by 5. Divisibility by 6 rule, if a number is divisible by both 3 and 2, the number is also divisible by 6. So, for a number to be divisible by 6, 1, the number should end with an even digit or 0 and 2, the sum of its digits should be divisible by 3. For example, 1, 63,924, the first condition is fulfilled as the last digit, 4, is an even number and also, 639i2 plus 4 equals 24 is divisible by 3, therefore, the number is divisible by 6. 2, 154, the first condition is fulfilled but not the second, therefore, the number is not divisible by 6. 3, 26 i.e. first condition is not fulfilled, therefore, we don't need to check for the second condition. Special cases. The rules for divisibility by 7, 13, 17, 19 are very much unique and are found very rarely. Before going on for the rule, we should know some terms like one more osculator and negative osculator. One more osculator means the number needs one more to be a multiple of 10. For example, osculator for 19 needs 1 to become 20, equals 2x10, thus osculator for 19 is 2, taken from 2x10 equals 20. Similarly, osculator for 49 is 5, taken from 5x10 equals 50. Negative osculator means the number should be reduced by 1 to be a multiple of 10. For example, negative osculator for 21 is 2, taken from 2x10 equals 20. Similarly, negative osculator for 51 is 5, taken from 5x10 equals 50. Note 1. What is IHE osculator for 7? Now, we look for that multiple of7 which is either less or more by 1 than a multiple of 10. For example, 7x3 equals 21, as 21 is 1 mtf then 2x10, our negative osculator is 2 for 7. And 7x7 equals 49 or 49 is 1 less than 5x10, our one more osculator is 5 for 7. Divisibility 39. Similarly, osculator for 13, 17, and 19 is, for 13, 13x3 equals 39, one more osculator is 4, from 4x10, for 17 17x3 equals
Divisibility 39. Similarly, osculator for 13, 17, and 19 is, for 13 13x3 is equal to 39, one more, osculator is 4, from 4 by 10, for 17 17x3 equals 51, negative osculator is 5, from 5 by 10 for 19 19x1. One more, osculator is 2, from 2 to the power of 10. 2. Can you define oscillators for 29, 39, 21, 31, 27, and 23? 3. Can you get any oscillator for an even number or a number ending with 5?
No.
But why? Divisibility by 7. First of all, we recall the oscillator for 7. Once again, for your convenience, as 7 times 3 is equal to 2 1 more than 2 by 10, our negative oscillator is 2. Leas oscillator, 2 is our key digit. This and only this digit is used to check the divisibility of any number by 7. See how it works. x1 is 112 divisible by 7? Son. Stepl.ll2 underscore 11 minus 2 times 2 is equal to 7 as 7 is divisible by 7. The number 112 is also divisible by 7. x2 is 2961 divisible by 7? Son. Step 1. 2261. 296 minus 1 times 2 is equal to 294. Stepl. 224. 29 minus 4 times 2 is equal to 21 as 21 is divisible by 7. The number is also divisible by 7. x3. 552. 77838, 552, 7783-8x2 equals 552, 7767 552,776, 255, 2,776 minus 7 times 2 is equal to 552,760, 255,276, 2. 55,276 minus 2 times 2 is equal to 55,272, 5,527, 2. 5,527 minus 2 times 2 is equal to 5,523, 55, 22, 552, 3x2 equals 546, 546, 54, 6x2 equals 42. As 42 is divisible by 7, the number is also divisible by 7. Not asterisk 1. In all the examples, each of the numbers obtained after the equal sign, equal symbol, is also divisible by 7. Whenever you find a number which looks divisible by 7, you may stop there and conclude the result without any hesitation. 2. The above calculations can be done in one line or even mentally.
Try to do so.
Divisibility by 8 rule. If last 3 digits of a number is divisible by 8, the number is also divisible by 8. Also, if last 3 digits of a number are zeros, the number is divisible by 8. "40 Quicker Maths Excel 12s6. As 2s6 is divisible by 8, the number is also divisible by 8. x2, 135,923 120. As 120 is divisible by 8, the number is also divisible by 8. x3, 139287000. As the number has 3 zeros at the end, the number is divisible by 8. Note: the same rule is applicable to check the divisibility by 125. Divisibility by 9 rule. If some of all the digits of a number is divisible by 9, the number is also divisible by 9. XL 3968 1. 3 plus 9 plus 6 plus 8 plus L equals 27 is divisible by 9, hence the number is also divisible by 9. X2 456,138. 4 plus 5 plus 6 plus 1 plus 3 plus 8 is equal to 27 is divisible by 9, hence the number is also divisible by 9. Divisibility by 10 rule. Any number which ends with 0 is divisible by 10. There is no need to discuss this rule. Divisibility by 11 rule. If sums of digits at odd and even places are equal or differ by a number divisible by 11, then the number is also divisible by 11. x1 324 5682. C equals 3 plus 4 plus 6 plus 2 is equal to 15 and C equals 2 plus 5 plus 8 is equal to 15 as S equals C. The number is divisible by 1. x2 2837 12. C equals 2 plus 3 plus 1 is equal to 6 and C equals 8 plus 7 plus 2 is equal to 17. As C and S2 differ by 1, divisible by 1, the number is also divisible by 1. x3 8492 729 1658. C equals 8 plus 9 plus 7 plus 9 plus 6 plus 8 is equal to 47, and S2 equals 4 plus 2 plus 2 plus L plus 5 equals 14 as C, smiley face. 33 is divisible by 1. The number is also divisible by 1. Divisibility by 12 rule. Any number which is divisible by both 4 and 3 is also divisible by 12. To check the divisibility by 12, we first divide the last 2-digit number by 4. If it is not divisible by 4, the number is not divisible by 12. If it is divisible by 4, then 2, check whether the number is divisible by 3 or not. x1 135792. 92 is divisible by 4 and also L plus 3 plus 5 plus 7 plus 9 plus 2 smiley face 27 is divisible by 3, hence the number is divisible by 12. Divisibility 41 remark. Recall the method for calculation of digit sum. What did you do earlier in 1SD chapter? Forget 9. Pound. Oh, the same here. For example, digit sum of 135,792 1 plus 3 plus 5 is 9. Forget it. 7 plus 2 is 9. Forget it. And finally we get nothing. Lie, it means all the forget 9 counts a number which is multiple of 9. Thus, the number is divisible by 9. Divisibility by 13 oscillator for 1 3 is 4, see note. But this time our oscillator is not negative, as in case of 7. It is one more oscillator. So, the working will be different now. Phi's can be seen in the following examples. x1 is 143 divisible by 13? Son, 142. 14 plus 3 times 4 is equal to 26. Since 26 is divisible by 13, the number 143 is also divisible by 13. Or, this working may further be simplified as step 1 14 3 16 4 by 3 from 142 plus 4 from 143. Step 2 1 4 3 26 sixteenths 4 by 6 from 1 6 plus 1 from 16 plus 1 from 143 equals 26. As 26 is divisible by 13, the number is also divisible by 13. Note, the working of second method is also very systematic. At the same time it is more acceptable, because it has less writing work. x2. Check the divisibility of 24,167 by 13. 2 4 16 7 26 6 20 34 4 by 7 from 2 4 1 6 2 plus 6 from 241 to the power of 7 equals 34. 4 by 4 from 3 4 plus 3 from 24 plus 1 from 2 4 1 6 7 equals 20. 4x0 from 2q plus 2 from 20 plus 4 from 2 4 1 6 7 equals 6. 4 by 6 from 5 plus 2 from 2 4 1 6 7 equals 26. Since 26 is divisible by 13, the number is also divisible by 13. Mark. Have you understood the working? If your answer is no, we suggest you to go through each step carefully. This is very simple and systematic calculation. x3. Check the divisibility of 6944808 by 13. Son. 694480839/18/12/41/19/32 4 times 8 plus 0 is equal to 32. 4 times 2 plus 3 plus 8 is equal to 19. 4 times 9 plus 1 plus 4 is equal to 41. 4xl plus 4 plus 4 equals 12. 42 quicker maths. 4x2 plus l plus 9 equals 18. 4 times 8 plus 1 plus 6 is equal to 39. Since 39 is divisible by 13, the given number is divisible by 13. Note: 1. This method is applicable for one more oscillator only. So we can't use this method in the case of 7. 2. This is a onkling method and you don't need to write the calculations during exams. These are given merely to make you understand well. Divisibility by 14/any number which is divisible by both 2 and 7 and also divisible by 14. That is, the number's last digit should be even and at the same time the number should be divisible by 7. Divisibility by 15. Any number which is divisible by both 3 and 5 is also divisible by 15. Divisibility by 16. Any number whose last 4-digit number is divisible by 16 is also divisible by 16. Divisibility by 17. Negative oscillator for 17 is 5, see note. The working for this is the same as in the case of 7. x1. Check the divisibility of 1904 by 17. So in 12q4, 190 minus 5 times 4 is equal to 170. Since 170 is divisible by 17, the given number is also divisible by 17. Note: students are suggested not to go up to the last calculation. Whenever you find the number divisible by the given number on right side of your calculation, stop further calculation and conclude the result. x2, 957508, 95,758, 95,750 minus 5 times 8 is equal to 95,710 210 9571 minus 5 times 0 is equal to 9,570 125 21 957. 5 times 1 is equal to 952 25 2. 95 minus 5 times 2 is equal to 85. Since 85 is divisible by 17, the given number is divisible by 17. x3, 897, 1563, 897,156 1, 897,156 minus 5 times 3 is equal to 897,140 1, 89,714 1. 89,714 minus 5 times 1 is equal to 89,709 8,972. 8,970 minus 5 times 9 is equal to 8,925. Divisibility 43 892 5. 892. SXS equals 867 260 2:86 5x 7 equals 51. Since 51 is divisible by 17, the given number is also divisible by 17. Divisibility by 18 Yiksai. Any number which is divisible by 9 and has its last digit, unit digit, even or 0, is divisible by 18. x1. 926568. Digit sum is multiple of 9, i.e., divisible by 9, and unit digit, 8, is even, hence the number is divisible by 18. x2. 273690. Digit sum is multiple of 9, and the number ends in 0, so the number is divisible by 18. Note: during the calculation of digit sum, follow the method of forget 9. If you get 0 at the end of your calculation, it means the digit sum is divisible by 9. Divisibility by 19. If you recall, the one more oscillator for 19 is 2. The method is similar to that of 1-3, which is well known to you. Let us take an example. x1, 14926 soln, 14926 19/9/12/11/14. Thus, our number is divisible by 19. Note: you must have understood the working. See the case of 1-3. Warning: empty page. Squaring of a number is largely used in mathematical calculations. There are so many rules for special cases. But we will discuss a general rule for squaring which is capable of universal application. This method is intimately connected with a procedure known as the duplex combination process and is of still greater importance and utility at the next step on the ladder, namely the easy and facile extraction of square roots. We now go on to a brief study of this procedure. Duplex combination process: the first one is by squaring, and the second one is by cross multiplication. And the present context, it is used in both senses, a caret and 2 In the case of a single central digit, the square is meant, and in the case of an even number of digits equidistant from the two ends, double the cross product is meant. A few examples will elucidate the procedure. XL, I or 2, duplex D, equals 2 caret equals 4x2.
For 8, det er lige med 8 er lige med 64 x3. For 34, det er lige med 2 gange 3 gange 4 er lige med 24 x4. For 79, det er lige med 2 gange 7 gange 9 er lige med 126 x5. For 103, det er lige med 2, lux 3, k er lige med 6 x6. For 346, det er lige med 2, 3 gange 6. Plus 4 er lige med 52 x7. For 096, det er lige med 2, 0 gange 6 plus 81 er lige med 81 x8.
For 1342, D equals 2, LX2, plus 2, 3 by 4, equals 28 x9. For 7358, D equals 2, 56, plus 2, 15, equals 142 x10. For 23564, D equals 2, 2 by 4, plus 2, 3 by 6, plus 5, equals 77x. 11. For 123456, D equals 2, 1x6, plus 2, 2 by 5, plus 2, 3 by 4, equals 56 now. We see the method of squaring in the following examples. Excel point 207 caret equals
J-solen 207, D for 2, D for 20, D for uge, D for
J Soln 207, D for 2 slash D for 20 slash D for OJ slash D for 07 slash D for 7 equals 2 slash 2, 2x0, slash 2, 2x7, plus 0 slash 2, 0x7, slash 7 equals 4 slash 0 slash 28 slash 0 slash 49 equals 4 slash 0 slash 28 slash 0 slash 49 equals 4 slash 0 plus 2 slash 8 slash 0 plus 4 slash 9 equals 42,849. 46 quicker maths. If you have understood the duplex method and its use in squaring, you may get the answer in a line. For example, 207 equals 422, 8449. Explanations. 1 duplex of 7 is 7 equals 49. Put the unit digit, 9, of duplex in answer line and carry the other, 4. 22x0x7 plus 4, carried, equals 4, write it down at second position. 32x2x7 plus 0 equals 28, write down 8 and carry over 2. 4. 2x2x0 plus 2, carried over, equals 2, write it down. 524, W write it down. Note, 1, if there are n digits in a number, the square will have either 2n or 2nl digits. 2. Participation of digits follows the same systematic pattern as in multiplication. Ex2, 897, equals 80, 64206 I 3049.
2. Participation of digits follows the same systematic pattern as in multiplication. Squaring of a number is largely used in mathematical calculations. There are so many rules for special cases. But we will discuss a general rule for squaring which is capable of universal application. This method is intimately connected with a procedure known as the duplex combination process and is of still greater importance and utility at the next step on the ladder, namely the easy and facile extraction of square roots. We now go on to a brief study of this procedure. Duplex combination process. The first one is by squaring, and the second one is by cross-multiplication. In the present context, it is used in both senses, a caret and 2ab. In the case of a single central digit, the square is meant, and in the case of an even number of digits equidistant from the two ends, double the cross product is meant. A few examples will elucidate the procedure. XL, I or 2, duplex D, equals 2 caret equals 4x2.
For 8, det er lige med 8 er lige med 64 x3. For 34, det er lige med 2 gange 3 gange.
For 8, D equals 8 equals 64 ex3. For 34, D equals 2x.
For 8, D er lige med 8 er lige med 64 x 3. For 4.
For 8, D equals 8 equals 64 ex3. For 34, D equals 2x. 3x4, equals 24 ex4. For 79, D equals 2x. 7x9, equals 126 ex5. For 103, D equals 2. LX3, K, equals 6 ex6. For 346, D equals 2. 3x6, plus 4 equals 52 ex7. For 096, D equals 2. 0x6, plus 81 equals 81 ex8. For 1342, D equals 2. LX2, plus 2. 3x4, equals 28 ex9. For 7358, D equals 2. 56, plus 2, 15, equals 142 ex10. For 23,564, D equals 2. 2x4, plus 2, 3x6, plus 5 equals 77 ex. 11, for 123,456, D equals 2. 1x6, plus 2, 2x5, plus 2, 3x4 equals 56. Now, we see the method of squaring in the following examples. XL.207 equals J soln 207, D for 2/D for 20/D for OJ/D for 07/D for 7 equals 2/2, 2x0/2, 2x7, plus 0/2, 0x7/7 equals 4/0/28/0/49 equals 4/0/28/0/49 equals 4/0 plus 2/8/0 plus 4/9 equals 42,849. 46 Quicker maths. If you have understood the duplex method and its use in squaring, you may get the answer in a line. For example, 207 equals 422,8449. Explanations. 1 duplex of 7 is 7 equals 49. Put the unit digit, 9, of duplex in answer line and carry the other, 4. 22x0x7 plus 4, carried, equals 4, write it down at second position. 32x2x7 plus 0 equals 28, write down 8 and carry over 2. 4. 2x2x0 plus 2, carried over, equals 2, write it down. 524, W write it down. Note, 1, if there are n digits in a number, the square will have either 2n or 2nl digits. 2. Participation of digits follows the same systematic pattern as in multiplication. Ex2, 897, equals 80. 64206 I 3049 equals 804,609. Explanations. 1.7 equals 49, write down 9 and carry over 4. 2. 2x9x7 plus 4, carried, equals 130, write down 0 and carry over 13. 3 2x8x7 9 plus 13 equals 206, W write down 6 and carry over 20. 4 2x8x9 plus 20 equals 164, write down 4 and carry over 16. 5.8 plus 16 equals 80, write it down. Ex3, I432, 2025302624 equals 205, 0624. Explanations. 1. 2 equals 4, write it down. 2 2x, 3x2, 12, write down 2 and carry over 1. 3. 2x, 4x2, plus 3 plus 1 equals 26, dump down 6 and carry over 2. 4 2, ix2, plus 2, 4x3, plus 2 equals 30, write down 0 and carry over 3. 5 2, 1x3, 4 plus 3 equals 25, write down 5 and carry over 2. 6. 2, 1x4, plus 2 equals 10, write down 0 and carry over I. 7l plus l equals 2, write it down. x4, 73,214, equals 5346403268229 I 796 equals 536,028, 9796 x5, 543,2819, equals 29455L 55 IJ 5 IO2 I62 I22 I28 66 I47268L equals 295155222867661. Practice Pyobolny, Q. Find the squares of the following numbers. 1. 835 2, 8432 3, 453214, 53000265, 7301092. Answers 1, 6972252, 710986243, 2053993014, 280927560665, 5330596191508624. Squaring 47. Note, to find the square of a fractional, decimal, number, we square the number without looking at decimal. After that we count the number of digits after the decimal in the original value. In the squared value, we place the decimal after double the number of digits after decimal in the original value. For example, 12.46 equals I5I5324555L36 equals 155.2516. Some special cases derived with help of duplex combination process. 1. Square of numbers from 51 to 59. We take a general representative of the numbers, from 51 to 59, say, 5a. Now, 5a, 5/2x5xa/a equals 25/10xa/a. We have 10xa equals a0 like 10x4 equals 40, 10x6 equals 60, etc. 5a equals 25/a0/a22 equals 25 plus a/a. Where a should be written as a two-digit number. Now, we see that our duplex combination process reduces to a simpler form. Using the above equation, x I51 equals 25f1/1 equals 26/01 equals 2601 ex 2 52 equals 25 plus 2/2f equals 27/04 equals 2704 ex 3 54 equals 25 plus 4/4 equals 29/16 equals 2916 ex 4 59 equals 25 plus 9/9 equals 34/81 equals 3481. 2. Square of a number with unit digit as 5. We take a general representative of such number, say, a5. Now, a5, a/2xa x 5/5 equals a/10xa/25 equals a/a0/25-10xa equals a0 equals a plus a/25 equals a plus i/25. Using the above equation, ex 1 15 equals 1x 1 plus 1/5 equals 2/25 equals 225 ex 2 25 equals 2x 2 plus l/5 minus 6/25 equals 625 ex 385 2 equals 8x 8 plus i/5 equals 72/25 equals 7225 ex 4 115 equals 11x 12/5 equals 132/25 equals 13,225 ex 5 225 equals 22x 23/5 equals 506/25 equals 50,625. 48. Quicker maths. 3. Square of a number which is nearer to 10. We use the algebraic formula equals x y plus equals x plus y x y plus y ex 1 98f equals 98 plus 2 98 to 2 plus 2 equals 9600 plus 4 equals 9604 ex 2 103 equals 103 to 3 103 plus 3 equals 10,600 plus 9 equals 10,609 ex 3 993 equals 993 plus 7 993 to 7 plus 7 equals 986,000 plus 49 equals 986,049 ex 4 1008 equals 1008 to 8 1008 plus 8 equals 101 6000 plus 64 equals 101 6064. To check the calculation we use the digit sum method for checking calculations in squaring. For example, in Excel, 207 equals 42849 digit sum 0 equals 0, hence, our calculation is correct. In X2, 897 equals 804,609 digit sum 6 equals 18 or 36 equals 18 or 0 equals 0 ITUs, our calculation is correct. In X3, 1432 equals 205,06242 digit sum 1 equals 1 or 1 equals 1 FUs, our calculation is correct. Note 1. Follow the forget 9 rule during the calculation of digit sum. 2. See all the calculations mentally. 3. Check the correctness of calculations in other examples without using pen. Square root. The method to get the square root of any number is similar to the procedure of division. The method of duplex is also used in the process of square rooting. So, we suggest you to go through the duplex process again. Before jumping on to the process of square root, we must know some fundamental principles related to square root. 1. The given number is first arranged in 2-digit groups from right to left, and a single digit if any left over at the left-hand end is counted as a single group by itself. 2. The number of digits in a square root will be the same as the number of digit groups in the given number itself including a single digit, if any. Thus 25 will be counted as one group, 1 as two groups and 21 as two groups. 3. If the square root contains n digits, the square must consist of 2n or 2nl digits, and conversely, if the given number has n digits, the square root will contain or digits. 4. But, in cases of pure decimals, the number of digits in the square is always double that in the square root. 5. The squares of first 9 natural numbers are 1, 4, 9, 16, 25, 36, 49, 64, and 81 respectively. This simply means a. that an exact square cannot end in 2, 3, 7, or 8. b. that a complete square ending in 1 must have either I or 9, mutual complements from 10, as the last digit of its square root. 2. That a square can end in 4, only if the square root ends in 2 or 8, a complement from 10. 3. That the ending of a square is 5 or 0 means that its square root 2 ends in 5 or 0 respectively. IV. That a square ending in 6 must have 4 or 6, a complement from 10, as the last digit in its square root. NV. That the termination of an exact square in 9 is possible, if and only if square root ends in 3 or 7, a complement from 10. In brief, it can be said that 1, s, 6 and 0 at the end of a number reproduce themselves as the last digits in their squares. 2. That squares of complements from 10 have the same last digit, lias. 50 quicker maths and 9, 2 and 8, 3 and 7, 4 and 6, 5, and 5, and 0 and 10 have the same ending, namely 1, 4, 9, 6, s and 0 respectively. And 3. That 2, 3, 7, and 8 are out of course altogether as the final digit of a perfect square. After having a brief knowledge regarding the square root principles now, we shift to the calculating procedure of square root. Step I. First arrange in 2-digit groups as suggested earlier in Prerequable 1. Step 2. First group from left should be separated from other groups by a vertical line. Step 3. Write down the digital square root value in answer row. For example, 61 13 64 answer row 7 here, 7i. Written because 8 is greater than 61. Other examples. Happy face, 73 60 84 here, 8 and 2 are written cause 9 is greater than 73 and 3 is greater than 8. Step 4. Now, write down the double of first answer digit at the place of divisor. For example, 14 61 13 64 and 7 Step V. Write down the remainder after subtraction of square of first answer digit from the first group as a prefix to the next dividend digit. For example, 1611-3 equals 2, which is written as a prefix of9, the next dividend digit. Step 6. Our next gross dividend number is thus 29. Without subtracting anything from it, we simply divide 29 by the divisor 6 and put down the second quotient digit 4 and the second remainder 5 in their proper places as usual. Square root 51 6 11 29 57 1634 Step 7. Thus our next gross dividend is 57. From this we subtract 16, the square of the second quotient digit, get 41 as the actual dividend, divided by 6 and set down the quotient 6 and remainder s in their proper places as usual. 6 11 29 57 5 I 6 3 4 6 step VLII. Our fourth gross dividend number is SI. From this we subtract the duplex of 46, the 2 quotient obtained earlier, which asterisk pound ohms to 2, 4x6, equals 48. We get 3 as remainder, divided by 6 and set down the quotient, 0, and the remainder, 3, in the R proper places. 611 29 57 5 liters 36 I3 I4 60 step 9. This gives us 36, our last gross dividend number. From this we subtract 36, the duplex OF460, 2x4x0 plus 6 equals 36. Wedge it 0 as remainder, which when divided by 6 gives 0 as quotient and remainder. 6 11 29 and LT 15 I 363 4600 as the number, 119716, has 6 digits, its square root will have 3 digits, so we put decimal after DE digits. Thus answer equals 346.00. Note: for a complete square number, when the process is continued into decimal part, all the quotient digits in the decimal part are found to be zeros and the remainders too are all zeros. Some more examples: XL, VJ29, 415H20904502230 equals 23, as there are 3 odd digits in the number of digits in its square root would be equals 2, so we put decimal after 2 digits. Offenser 12 40 49 16 0640 equals 64. 52 Quicker Maths EX3, 66, 2106 and do Euro M64012800. The above example is different from others. It needs some explanation. Up to the stage 210638441 there should not be any confusion. Now, our gross dividend is 6. If we divide it by 2, we can get 3 as quotient and 0 as remainder. In that case, 3 is our next gross dividend, which after subtracting 3 gives a negative value, thus we march toward an incalculative goal. A similar condition arises when we are left with 23-2 equals 19 as a real dividend. When we divide it by 2, we get 9 as quotient and 1 as remainder. But exactly the same condition is got when we are left with 38-2x2x8, smiley face, 6 as our real dividend. Try to solve it yourself. x4, vs 316321 x5, v7 389 15 489 14 53 4 liters 136 63 132 5 I74 7291 1.31, incomplete, 1733 58 59 13 liters 65 74 48 09 02 7183 3.0000. Decimal places: 16 73 92 12 I 160 148 5855. 633 x7, VO 009240 160, to 6 decimal places: 6000902 24 60 61 106 160.03039776 ANS equals 0.030397. Note: 1. Note that our first calculative group is 09 and not 00. Square root 53 asterisk 2. If you are required to find the answer up to 6 decimal places, we suggest you to find the 7th place also, because it checks the further viability of calculations. x8, 7, to 6 places of decimal, Soln 1027 2010 0901 2017 Lu 165. 1961524 ANS equals 5.1961524 x9, find the square root of 0.0000000831, to 8 places of decimal, Soln 18.000000083 2 I3020 IGO 706 registered trademark .00019 and 592 ANS equals .0009 1159 Practice problems 1. Solve x4, 5, 6, 7, 8, 9 yourself. Warning, empty page. Cubes of large numbers are rarely used. During our mathematical
calculations, we sometimes need the cube value of 2-digit numbers, thus O. An easy rule for calculating the cubes of 2-digit numbers is being given. In its process, the cube values of the first 10 natural numbers, i.e. 1 to 10, are used. Readers are suggested to remember the cubes of only these FNST 10 natural numbers.
1 علامة إقحام يساوي 1 2 علامة إقحام يساوي 8 3 علامة إقحام
1 equals 1, 2 equals 8, 3 equals 27, 4 equals 64, 5 equals 125, 6 equals 216, 7 equals 343, 8 equals 512, 9 equals 729 and 10 equals 1000. To calculate the cube value of two-digit numbers we proceed like this. Step I. The first thing we have to do is to put down the cube of the tens digit in a row of 4 figures. The other 3 numbers in the row of answer should be written in a geometrical ratio in the exact proportion which is there between the digits of the given number. Step 2. The second step is to put down, under the second and third numbers, just 2 times of second and third number. Then add up the 2 rows. For example, XL 12 equals Soln. Step I. We see that the 10 digit in the number is 1, so we write the cube of 1.
Step I. We see that the 10 digit in the number is 1, so we write the cube of 1. And also, as the ratio between land 2 is 1, 2, the next digits will be double the previous one. So, the first row is 12, 4, 8. Step 2. In the above row are second and third digits, from right, are 4 and 2 respectively. So, we write down 8 and 4 below 4 and 2 respectively. Then add up the 2 rows. 12, 4, 8, 4 underscore SI 728 is equal to 1728 x 2, 1 1 caret equals? Solve it yourself. x3, 16 caret equals? Soln. 1 6 36 216, 1 2, 7 2 4 3 0 129 216 is equal to 4096. 56 quicker maths explanations. 1 caret from 16 equals 1. So, 1 is our first digit in the first row. Digits of 16 are in the ratio 1, 6. Hence our other digits should be 1 times 6 is equal to 6. 6 times 6 is equal to 36. 36 times 6 is equal to 216. In the second row, double the second and third number is written. In the third row, we have to write down only 1 digit below each column, except under the last column which may have more than 1 digit. So, after putting down the unit digit, we carry over the rest to add up with the left-hand column. Here, I write down 6 of 216 and carry over 21. 2, 36 plus 72 plus 21, carried, equals 129. Write down 9 and carry over 12. 3, 6 plus 12, carried, equals 30. Write down 0 and carry over 3. 4, 1 plus 3, carried, equals 4. Write down 4. x4, 18 caret equals? Soln. 1 8 64 512 16 128 548 243 512 is equal to 5832 I. Write down 2 and carry over 51 of 512. 2, 64 plus 128 plus 51 is equal to 243. Write down 3 and carry over 24. 3, 8 plus 16 plus 24 is equal to 48. Write down 8 and carry over 4. 4, 1 plus 4 is equal to 5. Write it down. x5, 17 caret equals? Solve it yourself. x6, 1 9 caret equals? Solve it yourself. x7, 21 caret equals? Solo. 8 4 2 1 8 equals 2 caret. 8 plus 2 is equal to 4. For plus 2 is equal to 2. 2-5. 2 equals L. Since ratio is 2 to 184, 4 times 2 is equal to 8. 2 times 2 is equal to 4. Double is written below. 9I261 is equal to 9,261. Do you mark the difference? If no, go through the following explanations. Step I. 2 equals 8 is the first figure, from left, in the first row. 2. Ratio between the two digits is 2 to 1, i.e., the numbers should be halved subsequently. Therefore, the next three numbers in the first row should be 4, 2, and 1. Step 2. It should be clear to all of you because it has nothing new. Cube 57x8. 23 equals? Son. 8, 12, 18, 27, 24, 30, 6, 12, 4, L 56, 27 is equal to 12,167 explanations. Step I. 2 equals 8 the first figure, from left in the first row. 3, 2, 2:3 equals, the next numbers should be of the previous ones. So, we have 8x equals 12, 12x equals 18, 18x equals 27, 222x9, 33 equals? Son. 27, 27, 27, 27, 54, 54, 35, 89, 83, 27 is equal to 35,937 explanations. Step I. 3 equals 27 the first figure in first row. 2, 3:3 equals 1. 1 the subsequent numbers should be the same. X 1034 equals? Son. 27, 36, 48, 64, 72, 96, 39, 123, 15064 is equal to 39,304 F explanation. 3 equals 27 the first figure, from left, in the first row. 2. Ratio is 3 to 4, i.e., the next numbers should be y of their 4 previous ones. Here, 27x igual a 36, 36x igual a 48, 48x igual a 64. X11. 93 equals? Son. 729, 243, 81,27,486,162,804,753 245.27 is equal to 804,357 explanations. 9 equals 729 die first figure, phi left, tn the first row, 2. 9:3 equals 3. 1 equals, the subsequent figures should be y of their previous ones. $58 quicker maths x12. 97 equals? Son. 729,567,441,343 1134, 882, 912 1830, 613 57 343 is equal to 912,673 explanations. 9 equals 729 first figure, from left, in the first row. 7-2, ratio equals 9, 7 equals, next numbers should be of the previous ones. Therefore, 729x equals 7, 567x equals 441, 441x equals 343. Practice problems. Q. Find the cubes of the following numbers. 17 2.26, 3.274, 325.416.437.498.519.5, 310.552. 57 12.6, 413.6, 714.6, 915.7, 316.77, 17.88, 18.92, 19. 95 20.99. Answers 1. 49 13 2, 17,576 3, 1968 to the power of 4, 327,685, 689,216, 795,077, 117,649 8, 132,651 9, 148,877 10, 16637 511, 185193. 12. 262144413 30076 32850915 38901716 45653317 68147 77868819 85737 970 Note: don't use this method for getting the cubes of 20, 30, 40. Do you know the other quick method? Checking the correctness with the help of digit sum. Exodus 1 verse 12 equals 1728 digit sum. 3 caret equals 0. 7 plus 2 is equal to 9, forget it. 1 plus 8 is equal to 9, forget it. Or 0 is equal to 0, thus the cube value is correct. X2, 16 caret equals 4096 digit sum. T equals backslash or 49 7 equals I or for times 7 is equal to 1 or 28 is equal to 1 or 1 is equal to 1. Thus cube value is correct. Practice problem. Check all the calculations from x2 to x12 done in this chapter. Cube roots of exact cubes in this chapter. The quick method for getting the cube roots of exact cubes is being given. This method is completely at-sight method for up to 6-digit numbers. You don't need to write anything to get the answer. The method is totally based on inspection. Before jumping on to the procedure, we must know some well-known principles. 1. The lowest cubes, i.e., the cubes of the first 9 natural numbers, are 1, 8, 27, 64, 125, 216, 343, 512, and 729. Get it by heart. 2. Thus, they all have their own distinct endings, and there is no possibility of overlapping or doubt as in the case of squares. 3. Therefore, the last digit of the cube root of an exact cube is obvious. 1 cube ends in 1, then cube root ends in 1. 2 cube ends in 2, then cube root ends in 8. 3 cube ends in 3, then cube root ends in 7. 4 cube ends in 4, then cube root ends in 4. 5 cube ends in 5, then cube root ends in 5. 6 cube ends in 6, then cube root ends in 6. 7 cube ends in 7, then cube root ends in 3. 8 cube ends in 8, then cube root ends in 2. 9 cube ends in 9, then cube root ends in 9. 4. In other words, 1, 4, 5, 6, 9, and 0 repeat themselves in the cube ending, and 2, 2, 3, 7, and 8 have an interplay of complements from 10. 5. The number off digits in a cube root is the same as the number of 3-digit groups in the original cube, including a single digit or a double-digit group if there is any. 6. The first digit from left of the cube root will always be obvious from the first group in the cube. 7. Thus, the number off digits, the first digit and the last digit of the cube root of an exact cube are the data with which we start when we begin the work of extracting the cube root of an exact cube. For example, x1. Find the cube roots of the following values: 0, 17, 28, 2, 27, 44, 3, 3,375, 4, 15,625 v, 912,673 vi, 359,737, 804,357, 8, 13824 soln. Step I. Make groups of 3 digits starting from right. Thus 1 728. 60 quicker MADHS STQ. 2. As Tyra are 2 groups, the cube root will have 2 digits. Thus n equals 2. Step 3. Theory caret T hand groik, 728, ends in 8. Thus the city I will end in 2. Step 4. The left-hand group 1, when cube-rooted, gives 1. Thus we conclude n equals 2, left digit equals 1, right digit equals 2, therefore answer is 12. 2. Step I. 2 744. Step 2. Because there are only 2 groups n equals 2. Step 3. Right-hand group ends in 4, thus R digit equals 4. Step 4. Left-hand group, 2, is less than 2 and more than 1, thus L digit equals 1. L digit can't be 2 or more, why? Thus the value is 14. 375. Here n equals 2, R digit equals 5, L digit equals I, thus answer equals 15 for 15 6 25. Here n equals 2, R digit equals 5, L digit equals 2, as 15 is more than 2 carat and less than 3 carat. Answer equals 25V. 912 673. Thus, n equals 2, R digit equals 7, L digit equals 9, as 9 carat 9 12, 10 carat 6, 7 and 8. Solve yourself. Cube roots of numbers having 7, 8 or 9 digits. When we have a number with 7, 8 or 9 digits, the cube root of the number will have 3 digits, as there will be 3 groups of 3 digits taken at a time. In this case, we are required to do minor calculation in written. If we denote the left digit, the re carat t digit and the middle digit by L, R, and M respectively, then a relation exists between them which is used thereafter. For example, x1. Find the cube root of 33,076,161. So here R equals 1, L, 3, N equals 3. We need only M to get the exact value. Step I. Subtract R carat from the number and forget the last digit, 0, obtained after subtraction.
Like.
Cube roots of exact cubes 61,33,076,161 1 underscore as equals 1 carat equals 1. 33,070, 16 Step 2. Middle digit of the cube root is obtained by 3rm. 3r to the power of m equals 3x I 2xm equals 3m. Now, we are supposed that this 3rm is contained in 3307616. Since 3r to the power of m equals 3m is contained in 3307616, we may say that both should end with the same digit. Last digit of 3307616 is 6 and 3m should end in 6, hence m equals 2. Thus, we get all the 3 digits, L equals 3, M equals 2, and R equals L. Therefore, cube root of 33,076,161 is 321. x2. Find the cube root of 846,04519. Son. N equals 3, R equals 9, L equals 4, M equals? Step I. Subtract R carat from the number and forget the 0. As R carat equals 729, 846,045,19729, 846,039 Step 2. 3r to the power of m equals 3x81xm equals 243m as 846,039 is ending in 9, m equals 3 thus, we get all the 3 digits, L equals 4, m equals 3, and r equals 9 therefore, the cube root of the given number is 439. x3. Find the cube root of the exact cube 248858189. Son. Here, n equals 3, r equals 9, L equals 6, and m equals? Step I. 248858189,729,24885,746, as r equals 729. Step 2. 3r to the power of m equals 3x81xm equals 243m as 24885,746 is ending in 6, m equals 2. Thus, the cube root is 629. x4. Find the cube root of the exact cube 143055667. Son. N equals 3, R equals 3, L equals 5, and M equals? Step I. 143055667, 2714305564. Step 2. 3r equals 3x9xm equals 27m as 11305564 is ending in 4, m equals 2 thus, the cube root 523. 62 kc caret yar maths x5. Find the cube root of the exact cube, 10 s 823.8 I7. Son. Since the above value is the exact cube, our answer will be of 3 digits with decimal after 1 digit from right. To calculate the cube root, we don't need to kani the decimal. After calculating L, R, and M, we will put the decimal. Here, L equals 4, R equals 3, N equals 3, and M equals?
Step
1058238171058237 ASR caret equals 27. Step 11. 3r to the power of m equals 3x9xm equals 27m as 10582379 is ending in 9, m equals 7. Thus, the cube root of the given value equals 47.3x6. Find cube root of the exact cube 83.453453. Solve it yourself. Note: we don't need to go for the number which has more than 9 digits because it is rarely used. Cube rooting has also a general rule for all numbers, but it is useless to discuss it here as it needs some complex calculations.